Okay guys, it's Mr. Gibson here. I'm going to show you guys how you can solve exponential equations. The key here is to understand some stuff about inverses, okay? And the idea is if you plug an inverse into the function of that inverse, it produces just x, okay? They basically cancel each other out, okay? Log base b of x is the inverse of b of x, okay? That's another thing that you need to know is that logs are inverses of exponentials. So therefore, if I plug in an exponential into a logarithmic function of the same base like this, they'll basically cancel out and I'll be left with x, okay? That's going to be the key to doing all this. But the first example, I won't actually use logs, and that's because if I have the same base on both sides of my equation, then I can just cancel out the bases and use the exponent to solve, okay? And I'll show you guys what I mean. So I have 216 raised to the n minus 2 equals 6 to the second power, okay? Now, let's check something out. Let's see if 6 to the third equals 216. So look, I can actually rewrite this as 6 to the third, okay? Then I have 3 minus 2n equals 6 squared, okay? So, ignoring these bases on both sides, because all the action is going on up here in the exponential, I have 3 times 3 minus 2n equals 2. Now I'm just going to solve this equation like we would any normal equation and distribute this. 9 minus 6n equals 2, okay? And just keep solving from here. So minus 9, negative 6n equals negative 7, negative 6 divided n equals 7 6, okay? So the key here is that you get the same base. If you can get the same base, then you can cancel those bases out and just solve like a normal equation. Okay. Now, here's an example where that's not going to be so easy. So the first thing I want to do though is I want to get the exponential by itself. So I'm going to add 6 on both sides. Okay. So I have 19 raised to the negative 9b equals 98. Now I can't really think of any numbers that are that I could change 19 into a base that will equal 98. I really can't think of anything, or there's probably not. So what I'm going to do is I need to find another way to cancel this base, okay, to get rid of this exponential base. And the way we do that is by taking the inverse. Log base 19, because that's the inverse of 19 raised to the x, okay, 19 raised to the negative 9b. And like anything in algebra, if we do it to one side, we're going to do it to the other. So I can take the log base 19 of 98. Well, this is good because this will cancel. And I'm left with negative 9b equals log base 19 of 98. Okay. And if I want to solve for b, I'm just going to subtract divide negative 9 on both sides. And I get this right here. Now, if you want to keep it like that, I'm fine with that. But a lot of times, what you do is you have to make an approximation with your calculator. So I'll just let math log base. So there's log base 19 of 98, and I'm just going to divide that by negative 9, and this is approximately negative 0.17. Okay, so that's with logs, and this will always work as long as you use the exponential. A log with the same base as the exponential, they'll cancel out because of the properties of inverses. Now here's a special case, okay? Now, again, we want to get the exponential by itself, which is e raised to the 3m plus 7 equals 68. So I'm going to subtract 7 on both sides. Now I have e raised to the m, 3m equals 55. No, I'm losing my mind. 61. All right. Okay. So what makes this special is you're probably going, okay, well, we need to get rid of this e. Okay. E is not a variable. It's a special number called Euler's number. Okay. And what we're going to do is we're going to take the log base e of e raised to the 3m equals the log base e of 61. Now, e is such a special number, Euler's number, that there's actually a special log for this, and it's called the natural log. So it'll be ln for natural log of e raised to the 3m equals natural log of 61. Okay, so this cancels. I get 3m equals natural log of 61. Divide 3 on both sides. And I get m equals natural log of 61 over 3. Okay? So I don't even have to do log base. I can just hit this ln right here, ln of 61. Okay? Natural log of 61 divided by 3. And that equals approximately 1.37. Okay? So at this point, you guys have the tools to solve an exponential equation. And again, if you can't find a exponential of the same base on both sides or make it the same base on both sides, you can use this inverse property right here between logs and exponentials to solve it. All right. You'll have the notes on the next page, and make sure you guys finish the assignment. Thanks, bye.